Okay, thank you Chantal for updating me that question 14 and 33 there are some mistakes. So this video is to clarify that mistakes, and I think the reason why I make those mistakes is that I read the question too briefly. Okay, so let's begin with question 14. So question 14, actually question 14 is a very simple question, but in my previous video I actually make it much more complicated. So how to go about this is that it's the same process. We imagine that this disc is a full disc, there's no hole in it. So if this disc is a full disc and there's no hole in it, the CG is somewhere at the center. So now let's say the first hole is being drilled, this one. So when this hole is being drilled, some mass is being removed from the first and the fourth quadrant. So as a result, the CG will shift into the second and the third quadrant. So it will be along the line between second and third quadrant. Now what happens when the second hole is drilled? When the second hole is drilled, some mass is being removed in the second quadrant. It means that my CG will now definitely be in the third quadrant. So that is how you deduce the answer. You don't even need to draw or to find the average distance and all that. Okay, it's just steps of deduction. So I repeat, at the beginning, when the first hole is drilled, some mass is being removed from first and fourth quadrant. Therefore, your CG should be now in the second and the third. Okay, when you have a second hole drill in the second quadrant, you will know that the CG will now shift into the third quadrant, and that's how you solve this. Okay, as for question 33 again, I have read too fast and I didn't pay attention to the requirement of the question. Okay, so in this case, they are asking you the factor that explains why you get an electric shock. And in my previous video, I say that the answer is B because current is the one that gave you the electric shock. But if they ask you to explain why you get a shock, they are actually asking you to explain why there is a current flowing through you, right? Because electric shock is equivalent to a current flowing through you. So in order to explain why is there a current, you have to explain through potential difference, in this case voltage. Okay, so therefore it is definitely not A because moisture, you have moisture 24/7 in Singapore, and if that is the answer, I think you will have a very interesting and electrical life. Okay, and B is wrong. B is B is what causes an electric shock. It doesn't explain why you get one. Okay, and for part C, high voltage and low body resistance, that doesn't make sense. Even if your body resistance is low, you are drenched in water, but you are standing on a 2400 volt live wire, you won't get shocked. What I mean is that, let's say now you have a few wires. Okay, let me choose the right brush. Okay, this is your live wire. It is very high voltage. Okay, if you stand on it, okay, what happens is that the voltage on your body will be the same. Let's say the current will flow into your left feet. Your left feet will now be 240 volt, and then the go through, it will still be 240 volt. So because there's no potential difference, there will be no current and you won't die. That also explains why a bird can stand on an electrical cable, okay, without killing itself. So if you look at D tells you that there is a voltage difference, and it is because that there is a voltage difference, then you will have a current flowing through you which causes the electric shock. Okay, so that is the correct explanation, and if you found any mistakes in my video, please send me a WhatsApp and then I will update the video. Thank you.